Today's lecture is going to focus on section 3.3, dividing polynomials. We'll be looking at the first half of the section today, and in the next class, you'll be looking at the second part of the section. Okay, we're going to look at two different types of division of polynomials. The first type is long division, and the second type is synthetic division. So when we divide polynomials using long division, it's actually much like a regular long division of numbers. What you're going to have is you're going to have two polynomials. You're going to be dividing the divisor into the polynomial itself. Your divisor cannot be equal to 0. And then what you're going to get out of that when you divide it into it is you're going to get your quotient, which is denoted with this Q of x, and your remainder, which is the R of x. And R of x has to either be 0 or it has to be a degree that's less than the degree of the divisor. So you can stop with your dividing when your remainder degree is less than your divisor's degree. So there's two different ways for you to write your answer. So on WebAssign, they will specifically tell you which format to put it in, and we'll talk about how to put it in these. So here you've got the quotient plus the remainder over the divisor. And this one, the polynomial itself is equal to the divisor times the quotient plus the remainder. Okay, and this is just kind of showing you how to set this up. So you've got your dividend or your polynomial in here inside the division bracket. Your divisor goes on the outside, and then you have your quotient and your remainder that's going to be up top. Okay, so here's one that we're going to practice dividing using the long division. Okay, so with long division, we're going to put our divisor. This is our divisor. We're going to put it out here, and we're going to set up our division bar, and then we're going to write our polynomial. Okay, if I was missing any terms in between, I would need to put 0 as a placeholder. So for instance, if I didn't have an x term, I need to put a 0 here as a placeholder. Okay, so to divide this, I want to only look at this term and this term to start with. So I want to see how many times does x go into 6x squared? Or another way to think of that question is, what do I multiply x by to get 6x squared? So I need to multiply it by 6 and an x. Okay, the next thing I want to do is I want to then multiply that 6x by both of these terms in the divisor. Okay. So 6x times x is going to be 6x squared. 6x times 4 is going to be negative 24x. Okay, we want to subtract these, so that means we're going to change the signs. These will cancel, and we'll have negative 2x plus 12. And now we're just going to repeat the process. So I'm going to compare x to now negative 2x. So I would need to multiply this by a negative 2 to get it to match up to this. Okay, so I'll multiply that out. Negative 2 times x would be negative 2x. Negative 2 times negative 4 will be positive 8. We're going to subtract, which means we'll change our signs. And we're going to have 4. I don't have anything left to bring down, and so I'm going to stop here because my remainder, this is going to be my remainder. Okay, so my remainder has a degree of 0, and so it's less than the divisor. So as long as the degree of the remainder is less than the degree of the divisor, then I can stop. So as far as writing these expressions, so we've got one of our expressions, we said the polynomial was equal to the divisor times the quotient plus the remainder. Okay, so our polynomial was 6x squared minus 26x plus 12. So that's going to be equal to my divisor times my quotient plus my remainder. Okay, so that's one of the formats for the division algorithm. The other form I'm going to come up here and do, and that is the polynomial divided by the divisor equals the quotient plus the remainder over the divisor. Okay, so that's going to give me, my polynomial is 6x squared minus 26x plus 12 over x minus 4. That's going to be equal to, and I'm running out of room here, but it's going to be equal to my quotient plus my remainder over my divisor. Okay, here's another one to set up. So if I set this up, I'm going to put my divisor out here. So I'm going to have 2x squared minus x plus 2. And then my polynomial will go under here. I don't have an x to the third term, so I'm going to put a 0. So anything I'm missing, I need to fill in with a 0. So the only thing from x to the fourth down that I was missing was an x to the third. So I'll put a 0 here. Okay, so I'm going to compare first term to first term. And so that means this needs to be multiplied by a 4 and an x squared to get it to equal this. So then I'll multiply. So 4x times x times 2x squared would be 8x to the fourth. 4x squared times negative x will be negative 4x to the third. 4x squared times 2 is going to be 8x squared. Okay, so we're ready to subtract. So I'm going to change all my signs. These will cancel. I'll have 4x to the third minus 2x squared, and I'll bring down my minus 3x. Okay, next I want to compare these two. So I'm going to have to multiply this by a 2 and an x to get it to match up here. So 2x times 2x squared is going to give me 4x to the third. 2x times negative x will give me negative 2x squared. 2x times 2 will give me 4x. Okay, subtract. So change all of my signs. These will cancel, and it just so happens these also cancel. So I have negative 7x. Bring down the 1. Okay, so when I look here, this has a degree less than my divisor. So what that tells me is that I can now stop, and that's going to be my remainder. So when I go to write it in the format that it's asking for here, it's going to be my polynomial is equal to my divisor times my quotient plus my remainder. Okay, here's one for you to try. Okay, so we put the x minus 2 as the divisor, and here's our polynomial. So you can see that you're going to need to multiply x by 2x to get 2x squared. So we'll have 2x squared minus 4x. Change the signs. These are going to cancel. We'll end up with negative x minus 7. And so this needs to be multiplied by a negative 1 so that it matches up with this. Change our signs, and we end up with negative 9 as the remainder. Okay, here's another one for you to try. Okay, when we set this one up, the main thing here is to see that 0 is is going to need to be a placeholder for the x squared terms. So make sure that you put that in. And not only do you have to put placeholders here for the polynomial, you also potentially could have to put them for the divisor as well. So we don't have an example here where we would need to do that, but it is possible to have to put them in for the divisor as well. So you can see kind of how you go through on this one. Okay, and then we've got this example here to try. I'm actually going to go ahead and go through the steps on this one because I want to compare it to a way to do this using synthetic division. So here I'm going to divide x minus 3 into 2x to the third minus 7x squared plus 0x plus 5. And I will say the number one mistake I see people make is forgetting to put their placeholders. Okay, so if I multiply x by 2x squared, then it's going to give me my 2x to the third. And then 2x squared times 3 will be negative 6x squared. Change the signs. Okay, so x times negative x gives me negative x squared. Negative x times negative 3 gives me positive 3x. Change the signs. Okay, I look and my degrees are equal, so it means I need to go one more time. So looking at this, I need to multiply this by negative 3. So negative 3 times x will be negative 3x. Negative 3 times negative 3 would be positive 9. Change the signs and end up with negative 4 as the remainder. So my remainder would be, I would end up with this as my quotient plus the remainder over the divisor. Okay, so synthetic division is actually a much quicker method than long division, but it doesn't always work. So if you notice on long division, we really didn't have to worry about what we were dividing into it. This one was to the first power. This one was also to the first power. If we look back at this one, our divisor was to the second power. It really doesn't matter what we're dividing into it. They're all going to work the same for long division. But now when we get to synthetic division, it has to be something of the form x minus c that you're dividing into it. Or in other words, your divisor has to be to the first degree. So that it has to have a degree of 1. If it has any other degree, it's not going to work to do synthetic division. So this is the same problem that we just got through doing by long division. So I want to look at how it matches up to do this one by synthetic division. We can do it by synthetic division because we just have x to the first power. So what we want to do is we're going to make a little box, and we're going to take this, set it equal to 0, and we get 3. 3 is what's going to go here in the box. Okay. Now I'm going to take the coefficients of each of these terms. So I've got a 2, a negative 7. I'm still missing the 0 term. And then I have 5 for my constant. Okay, with synthetic division, the first thing I want to do is to bring this 2 down. Then I'm going to multiply the 2 times the 3, and I'm going to get 6, and I'll put that there. Okay, so I'm going to add these. And then I'm going to multiply the negative 1 out to the 3. I'll get negative 3. Add going down. Multiply going across. Add going down. Okay, so what I've got here, this is my remainder. And if you look back, that's the same remainder that we got. And my quotient, the way that I'm going to write my quotient is I'm going to keep these same coefficients, and I'm going to start 1 degree less than my original polynomial. So my original polynomial had a degree of 3. So this is going to start out as a second degree polynomial. So it'll be x squared, x, and then the constant. So my quotient is 2x squared minus x minus 3. My remainder is negative 4, and my divisor was x minus 3. So I end up with the same answer whether I do this by, excuse me, by long division or by synthetic division. Okay, so this is kind of just a screenshot of both to kind of show the comparison here. You still have to have your placeholders. If you look at the terms, this x minus 3, you're just going to simplify that to be the 3 here that you put into it. And you just kind of work through, and you see here's the 3, the 6, the 3, and the 9 that show up here. So it's just a little bit more condensed way to do that, and most people do like synthetic division better. The limitation is that it doesn't always work. So you can't just choose to do everything by synthetic division. You can do a lot of things by synthetic division, but some things you're going to still have to do by long division. Okay, so how to set up the synthetic division is pretty easy when it's an x plus 1, because we know that you're just going to change the sign essentially, and you're going to put -1 here in the box. This one's a little bit harder. It is still able to be done using synthetic division because it's to the first power. So I'm going to have 2x equals 1, so x is going to be 1/2, and that's what's going to go here in the box for this one. Okay, so I want to give you a minute to think about, first of all, which method you can or should use to do this one, and then I want you to try it. So you should have decided to do long division. This one would have to be done by long division because we have this squared term here. So I'm going to set this up and have 4x squared plus 0x plus 17 as my divisor. And then I'm going to have 8x to the 4th minus 4x to the 3rd plus 38x squared plus 0x plus 0. Okay, so we'll get started. Compare the 4x squared to the 8x squared. So I'm going to need to multiply it by 2x squared. Okay, this times 0 is going to be 0x to the 3rd. 2x squared times 17 is going to be 34x squared. Change all my signs. So those cancel. Got -4x to the 3rd plus 4x squared plus 0x. So now I need to multiply this by -x. So when I multiply this out, it's going to be -4x to the 3rd plus 0x squared minus 17x. Go through and change those signs. We got 4x squared plus 17x. My degrees are equal, so I can go one more time. So I need to think, what do I multiply 4x squared by to get 4x squared? And that answer is 1. So we definitely need to put that there. So 1 times 4x squared is 4x squared. 1 times 0x is 0x. And then I've got plus 17. Change the signs, and I end up with 17x minus 17. So my answer then is that I'm going to have 2x squared minus x plus 1, and then plus 17x minus 17 over 4x squared plus 17. Okay, here's another one for you to try. Again, think about which method would be appropriate to use, and then try using that method. So while this one could be done by long division, it also could be done by synthetic division. Synthetic would be quicker, so that's what I'm going to do here. My divisor is x minus 5, so that means 5 is going to go here in the box. So I'm going to have 3, -12, -9, and 1. I'll start out by bringing the 3 down. I'll multiply, add, multiply, add, multiply, and add. So my answer is going to be 3x. I started with a 3rd degree, so this is going to be x to the 2nd plus 3x plus 6 plus 31 over x minus 5. Okay, that takes us to the end of this first part of section 3.3. Please let me know if I can help you with any questions that you may have. Have a good day.